Hey guys, I'm back with the second problem. To this one is car fleet, basically. There are n cars in given miles away from the starting mile zero, okay? There's amount of cars that's going to this destination, just like real life, okay? It's a one lane road, so you cannot overtake any cars. Basically, a car fleet is like kind of like a lane of traffic, I guess. Um, if a faster car meets a slower car, it becomes one fleet, basically. So that's basically what it is. And we're returning the number of fleets in destination. So here's the intuition, right? First, think about physics, right? Let's look at the fleet. The fleets will come from the right to left, right? That's how we'll count the fleets because it would be easier that way if we count the fleets from right to left. So basically, what we have is a car fleet on the right, right? We calculate the estimated time of arrival of each car. We know if it's a fleet if the time of arrival, we know a new fleet has been added if the cars never meet. Because if the cars collide, if this one's faster than this one, right? And then they meet, that's still only one fleet, correct? Yeah, it's still only one fleet if a faster car meets the slow car. It's still one fleet. Basically, what this solution is, it sorts it. So we start from the end position in reverse order. So we start from the right. If you imagine the cars in the lane, we're starting from the car that's closest to the destination. We start from there. We calculate the estimated time of arrival. It's just the distance between the car and the target divided by the speed. It'll give you the estimated time of arrival. If the estimated time of arrival is greater than the slowest, so it will take slower, then we know a new fleet has been added because that car will never catch up. Therefore, it's two fleets, right? Because this car is going, this car will never catch up. That's two fleets. If it was faster, it would be one fleet because they would catch up and it would slow down to that speed. So one fleet of cars. That's basically, it's really simple once you think about it. Right? Here, I don't know if I can like draw it out. Basically, imagine there's a lane, right? Here's the lane. Here are the cars, okay? Here's the destination. Okay? Say this one, it's going to reach the destination in one time unit, okay? Or let's make it 2 time units. It'll reach it in 2 time units. And there's another car here. It's going faster, but it'll reach in 2.5 units, right? So this one will reach before. So first this one will go, it'll reach it, and then after, 30 seconds, this one will go. So that's two fleets. Why? Because this is greater. The time of arrival on this one is greater. Now, what if it was faster? Now, let's say this one will reach there in 3 minutes, but this one, I don't know, he's speeding or something. He'll reach it in 1 minute. Now, even if there was no car blocking, he'll reach in 1 minute. Now, because there's a car blocking him, right? He'll have to, and you cannot overtake. You can't overtake, right? Not allowed to overtake. He'll have to go behind this car, and therefore, that's still just one fleet of cars. This is just one fleet of cars. So basically, the intuition was, you have these fleet of cars, right? Each with the estimated time of arrival to the destination. Say this one will reach in 2 minutes, this will reach in 3 minutes, this will reach in 1 minute, this will reach in 1 minute, this will reach in 3 minutes, right? This will reach in 2 minutes. So if we have a slowest car, right, set it to 0 at the beginning, this should reach in 2 minutes. Because this is greater than the slowest car, but there is no car, it's just 0. This will be our first fleet. So we make this into 1, right? This one reached the destination. Now, we move on to the next one. All right. Is this greater than the slowest car? Yes. So this one will reach the destination and this one will never catch up. So now we change the slowest to 3. And now we have, hold on, where's my fleet variable? Just say F is fleet. We had one fleet first from this car. And then this one will become 2. This is now our second fleet, right? But think about it, this one will reach, so now we go to the next one. This is 1 minute. It'll reach in 1 minute. That's less than slowest. This will catch up and it'll become one fleet, correct? And this one will catch up and it'll become one fleet because they both take 1 minute to get to the destination, right? This one, again, it will also catch up. If it was 4, it would add one more fleet and it would end up with 3. But it's not. It's 3, so it will not catch. No, it will catch up because it's the same. It's not. They arrive at the same time. It's greater than the slowest. No, it won't. This will hit 3 minutes. Yeah, because they're equal, it still counts as one fleet, so you don't add a fleet. Okay, so we only have 3 fleets. So this one, our first fleet is this one that arrives in 2 minutes. This one, plus these, all these. So there will only be 2 fleets, correct? Only 2 fleets in this car. There's not a third fleet. That's what I meant to say. Because this arrives at the same time. If they arrive at the same time, that counts as one fleet. That's basically the problem intuition. And basically, here's the solution. Okay, we sort it. If it's greater than the slowest, then we add a new fleet. Because this implies that if it's less than or equal to the slowest, then it is part of the same fleet. That's what this is implying. If it's equal to or less than or equal to the slowest car, estimated time of arrival, it will be the same fleet, and we do not add the number of fleets, which is our answer. So if we submit that, we'll see we got a pretty decent runtime and a pretty decent memory time. And log event, because you sort the array, right? That's it. So this was pretty interesting because on NeetCode it's listed as a stack problem, but you don't actually need a stack to solve this problem. And that's basically